redo problem 80. So this is 7.5 problem 80. And it's talking about this page. And it has writing on it, and then the writing has a border. And that border, and it says the page of a book measures 6 inches by 9. So the distance from here to here is 6 inches. And then from here down to here, it's 9 inches. And it says a uniform border around the pages leaves 28 inches for the type. And I think I said the border was 28 inches, but actually it's this region in here is 28 inches squared. So the uniform border around the pages leaves 28 inches squared for the type. And I think I said that the 28 inches was the border. Oh, what did we get to?
We started 78.
Oh, we started 78? Okay, I'm going to do this one. Then I'll go back and do 78. So what it is, that border, the distance right here, you would say it's X away from there, and its distance here is X. It's evenly spaced. This distance is X. And this distance is X. So the border is even around it. So this 28 inches squared is going to be put into the formula where you say the area is equal to length times width. But the length you're going to be talking about is going to be a length from here down to here. And that length is 9 inches minus 2x. Because there's an x distance here and there's an x distance up here. Then the width, which is this distance here, is going to be 6 inches minus 2x, minus the two borders. So then that area, the typed area, which is 28 inches squared, is the length of 9 minus 2x times 6 minus 2x. And what they're going to want to know is they're going to want to know the length of that typed area, dimensions of the typed area, the length of the typed area, which is going to be 9 minus 2x. And they're going to want to know the width, which is 6 minus 2x. So those are the things that you're going to want to know. But you're going to solve that in terms of x. Yeah, click yes.
Sorry, but we don't have a copy of 7.5. I'm sorry.
The word problems. Okay.
Oh, not the 80, right? 78.
So now what you do is you use your algorithm and you expand this equation right here. So it's going to be 28, and you'll FOIL the left right-hand side. And I can just go ahead and FOIL it the way it is. It's going to be the first terms times each other. 6 times 9 is what? 54. Then the outside is a minus 18x. And the inside is a minus 12x. And the last terms is a plus 4x squared. Now what you want to do is get 0 by itself, and then in the process write it in descending order with leading term positive. So I'm going to get 0 on the left, move that 28 over to the right, and then I'm going to write this in descending order. 4x squared. The minus 18 and minus 12 is minus 30x. And then I'm going to take the 28 away from the 54. And I'll get 36 plus. Is that right? See where I got that? I'm taking this 28 away from this 54, and I should have, maybe I should have 26. 26? Is that better? Now you look for common factor, and there's no common variable factor, but at least a 2 will come out of there. A 4 won't. And you can just, rather than take the 2 out, as a factor, you can simply take 1/2 of this side and 1/2 of this side. And then you would have 0 equals 2x squared minus 15x plus 14. Is that right? No, 13. And you can divide. Now, I've got it written descending order, leading term positive. It's a trinomial. It's not a special case. So if it's going to factor, it's going to factor trial and error over the integers. So it's going to be x and an x. And now the signs are going to be, you look at the constant term, the sign in front of the 13 is positive, so you say same sign. Look at the middle term, what sign? Negative, both negatives, right? And now you look at the factors. 1 and 2 is the factors there, 1 and 13. Now is there such a way, 13? One and 13. So how do you do that? It's going to be a sum, right? It's a sum of 15. So you go the 1 with the 13 and the 2 with the 1, correct? So you put 1 and 13 down here. And then the 2 has to go with the 1, so the 2 would go there. And now you can check it out and you see the middle term is going to be negative 15. Now what do? Set each one of those equal to 0. X minus 1 equals 0. Or 2x minus 13 equals 0. This says x equals 1 or 2x equals 13. X equals 13 over 2, which is 6 1/3. Now, what's your answer? Well, if you look at this, you have two choices for x. X equals 1 or x equals 6 1/3. Which one of those is true? If x equals 1, then the length is going to be 7, right? 9 minus 2 times 1. And the width is going to be 4. 6 minus 2 times 1. If x is 6 1/3, then you got 9 minus 2 times 6 1/3. That's 12 2/3. What would that be? That would be a negative length. Would be such a thing as that? No. So you would insert the 1. Now that's not the answer to the problem. It's when you put 1 in for x. See, you would have 9 minus 2 times 1. So the length would be 7. There would be your answer. And then 6 minus 2 times 1, which would give you 4 for the width. So it's 7 by 4. So it's an example of doing a problem and then you have to indirectly get the answer because you can't do it directly. All right. Okay, I'll go back and do 78. The reason I think, I'm going to do all these problems because the odd ones right by them are quite similar. But in this problem I just did, if you don't do this first part of it, if you don't do this, I'm not going to give you any credit. Because anybody can look at the answer, and the answer is 7 by 4, and write that down, because it's in the answer key. The answer key is there just so you can verify that your process is right. You actually got it. Okay. 78 says the length of each side of a square is extended 5 inches. The area of the resulting square is 64 inches squared. Now sometimes what it's helpful to do, it says find the length and the width of the original square, is what's the formula you're going to be dealing with? Well, the area of a square is equal to the sides squared, right? Just take one side and square it. So then a picture, if you notice I've been drawing pictures, so that's fairly important to do. So I got my original square, and then they said they extended it 5 inches, so it goes out there 5 inches and it goes down there 5 inches. So then you just finish off that extended square, and then you say, well, this side, and you notice their little thing is S. Now, if I were going to do this, I would not put S, because if I write it fast, here's an S, and here's a 5. What can an S look like? A 5. So what I would do is I would change my variable, and I would say I want to solve for S, and I'm going to call it X. And then I would say this is 5 out here, and this is X, and this is 5, and it's extended. So the length from here to here is going to be X plus 5, and the length from here to here is going to be X plus 5. And notice that what I'm trying to find is X, length of original. Square. My formula is area equals side squared, and what they're giving me is they're giving me the area of the resulting square. So they're giving me the area of the large square as 64. So the 64 is the big square, and that's S plus 5 long quantity squared. Now we're going to S. This is X. Better do what I was thinking. X plus 5. Now what we want to do is expand it. We're going to learn that there's an easier way to do this in a little bit. Not now. We're going to have to expand the right-hand side. So that's 64 equals, when we binomial square expanded, it's the first term squared. 2 times the product of the first times the second is 10x. Second term squared is 25. Now we have to get 0 by itself on one side. And then when we take that away, what do we get? 29. Did I do that right? Minus. Minus 29, because I'm bringing this over as a negative 64 on this side and a negative 64 here. So then this is the quantity. It's a trinomial, it's not a special case, so we'll have to try this. It's an x and an x with the signs of what? Plus and minus. I wonder if I did that right. What? Okay. I was tempted to do that, but then I thought. Now is it right? That helps, doesn't it? So what two numbers times itself is 39, whose difference is 10? Yeah.
Just to make sure, did the 10x and the plus the 25 come from because it was a binomial? A binomial.
You mean this? How did I expand this? Is that what you're asking?
Yeah.
A binomial squared is always the first term squared, so you square the x, and then it's 2 times the product of the first times the second, so it's 2 times x times 5, which is 10x, and then it's the second term squared.
Right. I'll make sure.
Yeah. So what two numbers times itself is 39, whose difference is 10? 13 and 3. So what's positive, 13 or 3? 13 is positive and the 3 is negative. Now then we apply the principle x plus 13 equals 0, or x minus 3 equals 0, x equals minus 13, or x equals 3. So which one is it? X is equal to 3, right? Because you can't have a side negative 13 long. So the answer here is x equals 3, and I guess we should probably be carrying units, inches. That's what the original side was. Okay, does that? Now I look at 82. Says the length of a rectangle is 7 centimeters, the width is 4 centimeters, if both length and width are increased by equal amounts. The area of the rectangle is increased by 42 centimeters squared. Now you have to be really careful that you read the problem. And probably draw the thing out. This is 82. And it says it's 7 by 4. So this is going to be 7, and this is going to be 4. Now they said it increased by equal amounts. So this is going to be, this is increased, and this is increased, and they both should be equal. So then the resulting rectangle looks like that. Now I'm just going to have my increased amount, the whatever's increased by, I'm going to say this one's increased by X amount and this is increased by X. So the distance from here down to here is 4 plus X, and the distance from here over to here is 7 plus X. Now, notice the thing in that second sentence. It says the area of the rectangle is increased by 42 centimeters. So increased by, it's saying that this area right here is 42 centimeters, right?
Mm-hmm.
It's increased by that much. So this is what a formula would be, the way you could figure it out. If you called the small rectangle A1 area of original rectangle, and area 2, the A2, as the area of larger rectangle. Then if you take A2 and subtract A1, you should get what? 42 centimeters squared. Is that right? Now, the formula we're going to use is going to be area equals length times width. And the thing I'm trying to figure out, find the length and width of the larger rectangle. So what I want to know is 7 plus X and 4 plus X, right? I want to know 7 plus X and 4 plus X. Length of the larger. So this would be L2 and width 2. That's what I'm trying to calculate. And what I'm going to do is I'm going to have to calculate X and then figure out what the length and width are. So the area of the larger is length times width. So I'll put 7 plus x times 4 plus x. That's the larger rectangle, right? And the smaller one is 7 times 4, right? And that's equal to, the difference of the two areas is 42 centimeters squared. So now with that problem, I got to use my algorithm, and it says what? First of all, expand it. So we FOIL it. So 7 times 4, first term's 28, right? Outside plus 7x. Inside plus 4x. Last plus x squared. Minus 7 times 4 is 28 equals 42. Now I want to get 0 by itself on one side. I want to get this written in descending order, leading term positive. So I'm going to take everything left, right? Because my leading term is x squared on the left-hand side. My linear term is 7x plus 4x is 11x. The 28s on the left-hand side cancel out, right? And that means the minus 42 that comes over, and then I have 0. So now I'm looking at that trinomial, no common factor, descending order, leading term positive, not a special case trinomial. I'm going to factor trial and error over the integers. It's going to be x and x with signs what? Opposite signs, right? Because it's a minus 42. Two numbers times itself is 42, whose difference is 11. So what am I doing? I'm just going to have to go down. I'm going to have to go 1 times 42. That's 41. 2 times 21. Difference is what? 19. 3 times 1, 4. And there it is. Now, which one's positive and which one's negative? 14 positive, the 3 negative. Now what do I do? Apply the principle. Set each one of my factors equal to 0. That says x equals minus 14, or x equals 3. Well, which one is the reasonable answer? X is 3, right? So what I'm doing is I'm going to put in here, I'm going to put x is 3. So it's 7 plus 3. My answer is 10, right? 4 plus 3 is 7. There are my length and width of my sides, and those are measured in what? Centimeters. And you notice, does it work? You know, it's a difference. It'd be 70 minus the 28, and that's 42. So what I'm looking for, when I'm looking at these problems, I'm looking for this stuff right in here. I'm looking for your setup. How did you set it up to be able to do the problem? If you draw, and I think if you draw a picture, it'll help you tremendously in solving problems. 84. It says solve p cubed equals 9p squared. So what are you going to do with that thing? We'll just follow the algorithm. Expand, nothing to expand. Get 0 by itself. What are you going to have to do there? Write it in descending order. On one side, leading term positive, you would subtract 9p squared from both sides, and you get 0. Then you look at what's the next thing it says to do. Common factor, you take the p squared out, right? And then you'd have p minus 9. Now then, it's completely factored, and you would apply the principle, p squared equals 0, or p minus 9 equals 0. So p has to equal 0, or p equals 9. And it just says solve. So these are your two solutions to that problem. '86 says find 3n squared if n times n plus 5 equals minus 4. So what are you going to have to do with that? Just look at the algorithm. What's it say first to do with it? Expand it. N squared plus 5n equals minus 4. Then what? 0 by itself. Trinomial, it's not a special case. Trial and error with integers. It's an n and an n. What are the signs? Both positive. Two numbers times itself, whose sum is 5. 4 and 1. This says n plus 4 equals 0. 4, n plus 1 equals 0. N equals minus 4. 4, n equals minus 1. So there's no way to specify which one of those n's. I guess you could. Both of those satisfy it, so then what you do is you take that minus 4, there's two answers. One of them is 3 times minus 4 squared, which is 3 times 16 is 48, is that right? And then 3 times a minus 1 squared, which is 3. So either one of those is your answer. So that's, any questions on word problems? On Wednesday, hand those odd problems in, completed, and then hand them. That'll be, how many are there? There's 11 or so. 5 points apiece. 55 points, or 60, or whatever those things are. And this next section is rational polynomial. So what it is a polynomial divided by a polynomial. So an example of a rational polynomial, number 4 on that sheet, it's 16x squared y over 24xy cubed. Notice you have a monomial in the numerator, a monomial in the denominator. And rational means that it's a polynomial divided by a polynomial. Because a rational number, what's the definition of a rational number? you might have learned it as a terminating decimal or a non-terminating but repeating decimal. That's really not it. What it is, it's an integer divided by an integer. Rational means dividing something. So in this case, it's a rational polynomial, and we have a monomial divided by a monomial. Now, what you want to do is simplify it. So you take each one of these term by term. You take the numerical coefficients, the 16 and 24, and you look at 16 and 24 and say, is there something in common that they have? 8. And you'll take the 8 out. So if you take the 8 out of the 16, you see you would write that 16 as 8 times 2, and you'd write that 24 as 8 times 3. And then you would isolate the 8 over 8, and 8 over 8 is 1. That goes out. So it leaves you 2 over 3. Now the easy way to do it is you just say the 8 is there, and you just cross this out and say that's 2 and that's 3. Now on the next one, what you do is you take your x squared over your x. Now simplifying that is you would have it written as a positive exponent. Well, that is a positive exponent when it's written in the numerator. That is, you would write this as x to the 2 minus the 1 in the denominator, which is x. But typically what you would do with this thing, you cross this thing out. I would suggest that you cross this out completely and just say what I have is x left. Then you take the y over y cubed. Now, the positive exponent, you'd have to go into the denominator, and you'd go y to the 3 minus 1 in the denominator, which is going to be 2. Best way to do is cross the y out. Now, you can do it this way. You could cross the 3 out and put 2. Probably better is to cross the whole thing out and write y squared. Now what you have left is in the numerator you have a 2x, in the denominator you have a 3y squared. And that's your answer to the problem. Okay, now then 8 says 5 minus 2x over 2x minus 5. Now, you would look at that and you'd say, kind of looks close, but not quite. But now if you took a negative sign out of the numerator and wrote that numerator as a negative minus 5 plus 2x over 2x minus 5. And then you wrote this negative sign out in front, and then changed the order of the numerator, you'd have 2x minus 5 over 2x minus 5. And this line right here being your brackets for the numerator and denominator. Now then, you have two numbers identical over top of each other. And this cancels with that. And what do you have left? Minus 1. Okay, the next one. 12. It says 14x, I want to write this thing down. 14x cubed times 7 minus 3x. And then 21x times 3x minus 7. Now, what you would probably want to do with this thing is you want to cross this out and say this thing is 3x minus 7, but I'd have to have a minus sign out front. Right? I've taken the minus sign out. Now then, you'd look at the 14 over 21, and you'd say this 7 comes out, 2 over 3. You'd look at your x's. Cross this out, you'd say this is going to be x squared. Then the 3x minus 7, 3x minus 7, and the answer is a negative 2x squared over 3. You could write it as a negative 2/3 x squared. Whichever way helps you the most in doing the problem. Any questions on that?
It's easy.
What?
It's easy.
Okay. 16. Five x y minus 3y over 9 minus 15y. Now, if you look at that numerator, you can see there's a common factor, right? So write that thing as a y up front, 5x minus 3. Then you look at that denominator, and you say, if I switch that 9 and minus 15 around, pulling a minus sign out, thinking of it as this way, 15y minus 9, I would have to have a minus sign out in front, right? Yeah.
I think it's probably that wrong. Let's say 15x already. I'm not sure.
Is that this 16? 5xy minus 3y, 9 minus 15x. Okay. This was supposed to be an x. Is that right? Thanks. So then that would make this one an x. So this would be 15x minus 9. Now then, that 15 minus 9 is actually, you could pull a 3 out of it, couldn't you? So then that would be a 3 times 5x minus 9. Now notice that you have a 5x minus 9, that when you put them over top of each other, they're 1, and all it leaves me is a negative y in the numerator over 3. Now you could write that as a negative 1/3 y. Whatever kind of works in the problem you're working with. But this would be okay. I'll do one more. A squared, it's a 20. A squared plus 7, I don't know why. Go up. A squared plus 7a minus 8. A squared plus 6a minus 7. Now you look at that top and notice that the trinomial descending order leading term is positive, and if that factors, it's going to factor, and it's going to be what? A plus 8, A minus 1, and that denominator will factor into A, and a plus minus, and that's going to be A plus 7, A minus 1. You see, this cancels with that. What I have left is an A plus 8 over an A plus 7. And that's my answer. Now I don't have to put brackets around them because this line brackets. So that's it.